When it comes to building a user interface with Sencha Touch, the tab panel and toolbar are two components that you are going to find indispensable. In this screencast, we'll find out how to create a tabbed interface with icons, and we'll also see how toolbars can hold buttons or simply be used as a title bar. I've already set up the application structure, which currently consists of an app.js file and a viewport.js file in the views directory. As you can see, the app.js file defines a launch function, which instantiates a viewport object. The viewport object extends the default panel, but right now the only customization is to make the viewport full screen. We'll be adding more specialized behavior to this class later. If we look at this in the browser, there's nothing to see except that the entire screen is a light grey. So let's start building a user interface. The first thing we want to do is to make the viewport extend the tab panel class instead of the regular panel. The tab panel can be used as a container for other components. It automatically creates a tab bar with buttons which, when clicked, activate their corresponding card. To begin with, we'll just create a simple list of items in line, each with a title. Now we've got 5 tabs, but there's no content in any of them, so let's just add some placeholder content to each one of them. I could do this by adding an HTML attribute to each item, but since I want to reuse the same value, a quicker way of doing it is to specify an object called defaults. The values specified here will be automatically applied to every object in the items array. So now you can see that when I click on a tab, the placeholder text for the current card slides out of view to be replaced by the placeholder text for the newly activated tab. Note that the tab bar is docked to the top of the screen by default. Now, watch what happens when I override this by setting dock to bottom for the tab bar. I'm also telling the layout to center the buttons using the pack property. When the tab bar is docked to the bottom of the screen, the buttons take on a different appearance. The text is much smaller, and right now the clickable area looks too small. Well, there's a reason for this. When a tab bar is docked to the bottom, it is expected that you provide an icon for each button. We can do this simply by adding an icon CLS property to each of the items in the tab panel. That looks more like it. Sencha Touch comes bundled with over 300 beautiful icons designed by Drew Wilson. If you open up the Sencha Touch package that you downloaded from the website, you can find the icons by navigating through Resources, Themes, Images, Default, Pictos. You can use any of these buttons for your tab bar, but first you have to create a rule in your style sheet. We'll learn how to do this later when we discuss theming Sencha Touch apps. Until then, there are a handful of icons that are already included in the default Sencha Touch style sheets. If you want to find out which ones these are, open the file resources css-debug sencha-touch.css and search for the pattern .x-tab img. The class on the image corresponds to the name of an icon in the Pictos directory, so you can use any of these without having to compile a custom theme. There is another property that can be used with tab buttons, and that is badge text. For the sake of demonstration, I'm going to set it to 1 for the Home tab. As you can see, that creates a badge with the specified text overlaid on top of the button. This is great for drawing attention to things like unread messages or pending tasks. In practice, though, it is more likely that you will want to set the badge text dynamically rather than hard-coding it into the configuration. We'll see how to do this a little later in this screencast. We've set up a basic user interface. The next step would be to start fleshing out the specialized behavior for each of the cards inside the viewport. But before we do that, I'm going to rearrange things so that the configuration for each item in the viewport has a file of its own. Let's start by creating a file for the home card in the app/views directory. Here, we'll create a specialized version of the panel class, assigning it to the toolbardemo.views namespace. Having created this custom class, we can then call the ext.reg function to register an X-type of home card. Don't forget to link to this file in the index.html file. In the viewport class, we've currently got a list of objects that define the properties for each panel in line. Having created a customized view for the home card, we can now replace this inline definition with the home card X type. Now, when the application launches, the viewport will create an instance of the home card class on demand. We can do the same thing for the remaining panels, replacing each inline definition with a custom X type. We also need to create the custom classes in their own files, and link to them from the index.html file. But you don't need to watch me doing the same thing 5 times, so I've done it off camera. All we've done here is to move things around, so it should look just the same as before. But keeping each view in a separate file makes it easier to keep things organised. Next, we want to customise each card. Starting with the home card, I'm going to turn this into a tab panel and add 2 items with a little information about tabs and toolbars. I've customised a few of the other panels off camera. If you want to see how I did it, you can view the source code on GitHub. Note that on a mobile device, you won't be able to fit more than 5 buttons along the bottom of the screen. So if you need more than 5 cards, a common user interface pattern is to make the last button say More, and make it into a list or a nested list that gives access to more cards. Here I'm using a nested list. Note that it includes a toolbar, and when I activate one of the child panels, it automatically adds a back button to the toolbar. Next, we'll look at how to add a toolbar to each of the other panels. Toolbars should be docked to the top or bottom of a panel. So we can create a configuration object with the X type set to toolbar and add it to the list of docked items. Now we have a toolbar, but it looks a bit bare. For now, we'll just add a title, using the same text as the tab button. I've done the same for the search and action panels, so now when we switch tabs, there is always a toolbar with a title, or in the case of the home card, a tab bar, which takes up the same amount of space. So far, we've just added titles to our toolbars, but the name suggests that there is more to them than that. Toolbars are a natural place to put buttons. Let's add some buttons to the toolbar in the action card. Normally, if you wanted to set up a configuration object for creating a button, you would have to set the X type to button. But in the context of a toolbar, this is the default. It is as if you had created a defaults object with X type set to button. Here we have 2 buttons side by side, which looks a bit crowded. Let's add a spacer element between them. This will expand to take up all of the available space in the toolbar, minus the width of the 2 buttons. There we go, that looks better. Earlier on, I promised that we'd learn how to set the badge text on a tab dynamically. These buttons invite interaction, so this seems like a good time to return to the topic. Let's set this up so that clicking the ping button makes a badge appear on the tab button for the home card. To do this, we first have to set up a reference to the home card instance so that we can manipulate it. In the launch function, I'm going to create a home card variable inside of the toolbardemo.views namespace. The home card component is contained inside the viewport, so we can obtain a reference to it by calling getComponent on the viewport. This function expects an argument representing the identifier of the component that you want to retrieve. I'm going to use home here, but for this to work, I'll have to ensure that the home card uses this identifier. Now, I just need to make sure that I assign an ID of home to the home card when it is created. Let's reload the application in the browser and check the console to see if we've set things up correctly. I should be able to type toolbardemo.views.homecard and it will return a reference to the panel. From here, we can reach the corresponding tab, then call the setBadge function on it. There we go. Now we have a reference to the home card. We can use this in the context of a button handler. Now we can implement the handler function for the ping button. This function should increment the count each time it is triggered. Then we can also set the clear button handler so that it resets the badge text. Now, each time I click the ping button, the number in the badge text increases, and the badge is cleared when I press clear. I've created a few more toolbars to demonstrate some of the ways that buttons can be styled. The UI property of a button can be used to tweak its shape and colour. Back and forwards can be used to shape the button like an arrow, whilst small and round do just what they say. You can change the colour of a button to hint that it calls to action, confirms, or declines an operation. These create buttons that are blue, green, and red, respectively. You can also mix and match certain pairs of colour and shape, allowing for action round, action small, confirm round buttons, and so on. It's also possible to use an icon with a button, either to complement the text or to replace it. The same set of icons that were available for creating tab buttons can also be used for buttons in a toolbar. You just have to set the icon mask property to true and set the icon CLS property to the name of the icon that you want to use. Here, I'm using a star icon. In addition to the usual action, confirm, and decline styles, there is a plain style which draws the icon without a surrounding box. This responds to being touched by glowing with a blue halo, whereas the other button styles take on an inverted appearance when touched. I like this style, so I'm going to change the clear and ping buttons to use a cross and a star icon, respectively. Let's see how it looks in the iPhone simulator. That looks good to me. The code used in this demonstration can be found on GitHub. I've created a separate branch for every checkpoint, so each time you see a card like this one, it means that you can check out a snapshot of the code in its current state at that point in the screencast. You can find instructions on how to view these snapshots in the repository's README file.